Hello friends, welcome to the new semester. In this semester we will study digital electronics. Now, in electronics, if we divide the complete electronics family, electronic circuits family, then there are two types of circuits are available. First is your analog circuit and second is your digital circuit. Now, the analog circuit, in case of analog circuit, your signal is your analog signal and in case of digital circuits the signal is of type of is known as digital signal. Okay, now consider a signal here. First, suppose that if we have temperature of our surroundings throughout the day time, that is at midnight, then 1 a.m., then 2 a.m., then 3 a.m., and up to like this, then up to 11 p.m., and then 12 p.m. Okay, then you can say that the temperature moves like this. If this is your 12 p.m., then the temperature increases, and the near the 12 p.m. it becomes up and down like this, and then again goes down, and then again you can say that goes up, starts up. Okay, so we can say that this is a function which has continuous in nature, and this function is actually it is a continuous function of time. Okay, now if we have 2 points on this function, suppose these 2 points are a and b, then between these 2 points there are number of points are available, infinite number of points are available, infinite number of values are available, you can say that. Okay, but if we discretize this circuit like this, suppose the same circuit is again we consider here. Okay, the same circuit is considered here, but we sampled it actually at different instant. Sampled means we take values at different intervals of time. Let us suppose after every hour, like this. Then your signal now becomes, that is we represent here it in downwards, that the same signal is now converted into a discrete signal with having values at some regular intervals like this. Okay, and this is not a continuous signal. This signal is actually a discrete signal. This is a discrete signal. These type of signals are generally known as digital signals. Okay, now if we quantize this signal, that we set two values, whether the temperature is above 30 degree, sorry, whether the temperature is above our room temperature 27 degree or below 27 degree, then you can say that in this part of region your temperature is higher than your 27 degree, whereas in this region the temperature is below 27 degree. So there are two values available, less than 27 degree or greater than 27 degree. 27 degree. Okay. Now take another example in this way. Suppose we have a glass here and we fill some water in it, like this, and at this instant you can say that this glass is not actually full, not empty, but it has some value here. And assume that the another case here, that the glass contains this amount of water. Again it's not empty, again it's not full. You can say that both of these glass, that is glass 1 and glass 2, has some water. But if we quantize them, let us suppose this line represents its middle line, and if this is line the threshold line of upper threshold, and this is the lower threshold line, then you can see that if a glass contains water above the upper threshold, then it is known as a full of water glass, and that is known as full. And if it contains less than lower threshold limit, then it comes under the category of empty glass. Okay, this is your full glass, this is your empty glass. So we characterize the condition according to these two positions, that whether the glass is full to be considered or empty to be considered, and we assign two different values, that is either 0 or 1, and these 0 and 1 can also be written as low or high. Okay, so we actually digitized this analog part to the digital world. in this way that we put some labels or values or limits, we set some limits so that we can find out the actual output, that what actual output is there, whether it is fully filled glass or a empty filled glass, empty glass. Okay, so in this way we have to convert this system from analog to digital system. Now take another example. Suppose this is a mic here, and this receives voice. The voice it receives is actually a analog signal. Okay, and this voice, after amplified by this amplifier and then goes into the speaker, then again the voice is your analog. Now if we want to convert this analog voice to the digital voice, then we have to put here some circuit that is known as your analog to digital converter, that is A to D converter. And here, because we have to again convert back it to the analog form, then here we have to add some additional circuit, that is digital to analog converter. So in this way, this subject is very important to understand these concepts, that is what is actually a digital signal and what is actually a analog signal. Okay, we have to differentiate between both of these two. Okay, now come to the part that which books you can refer for these two, this subject, as a textbook or as a reference book. First is your digital fundamentals by Thomas L. Floyd, from Pearson Education. And the second is Fundamentals of Digital Electronics by R.P. Jain. Third is Digital Electronics by Morris Mano. Okay, we will follow these three books throughout this semester. Thank you for watching this video.